Good morning, everyone. I am Teacher Lizelle, and I am your teacher for today. Today, I will discuss to you about statistics. Teaching statistics and probability in grade 6. Statistics and probability are essential for a wide range of academic and social fields. Often, the materials are introduced in a way that fails to appeal to children's prior knowledge base. When statistics and probability are taught in the abstract, children dismiss it as irrelevant. Our topic, teaching statistics by making graph, collecting and illustrating data using line graph. Our learning objective, students will create a line graph using their collected data. So I have here some pictures on the board. So what have you noticed on the pictures on the board? So there are pictures that can only take certain values and there are pictures that can take any value. Meaning some of the pictures' value can be changed over time and some are not because they cannot be broken down into halves. Okay, so now let us classify them one by one. Anybody who can classify the first picture on the board? That is the number of eggs in a basket. Please choose if the picture can take a certain value or it can take any value. Okay, the first picture can take a certain value. Why? Because the number of eggs in a basket cannot be broken down into fractions or into halves. There must be 15 eggs in a basket, but cannot be 15 and a half of eggs in a basket. Number 2 is the picture can take a certain value or it can take any value. The picture shows the height of a child. Okay, the picture can take any value. Why? Because the height of the child can change over time and it can be broken down into fractions or decimals. Number 3, that is a temperature. Where do you classify it? The picture can take any value. Number 4, the picture is the Facebook likes. Where do you classify it? The picture can take a certain value. Number 5, how that shows the wind speed. Where do you classify it? Picture can take any value. For number 6, the weight of a person. Where do you classify it? The picture can take any value. For our number 7 and number 8, that pictures can take certain values. And now that you understand the difference between the two, I will discuss to you about the two types of data and data line graph. So there are two types of line graph. The two types of line graph are discrete and continuous data line graph. What is discrete data? So discrete data, it cannot be broken down into fractions or decimals. It can be easily visualized and demonstrated using simple statistical methods. Its values can only take a certain values, and its graph contains of isolated points. So for examples, who can give an example for a discrete data? Anybody? Okay, like for example, people. Because people, you cannot have it half of a person. In purchasing tickets, you cannot buy or purchase only half of the ticket. It must be one or a whole. How about continuous data? It is able to break down into fractions and decimals, changes over time, and can have different values at different time intervals. Values can take any value, and its graph is unbroken. For examples, time, because time changes over time, and temperature, because temperature can be high or low over time. So meaning, all those pictures in our first slide classified with these two types of data. All those pictures that can take only a certain value is called discrete data, and the pictures that can take any value is called the continuous data. And now that you know the two types of data and data line graph, let us proceed in collecting data and creating a graph. Let us proceed to the discrete data collection. So for our activity 1, what we are going to do is to record the number of sips you had each time you drank some water. So here in our activity 1, it is collecting data and creating discrete data line graph. So here is our graph. And first, we have to make a table. Next, we will put our title at the top center of the graph. And the title is amount of water used, since we are going to record each time you sips water. Then we number each columns and rows starting with zeros. Then let's label our axes, the x-axis and the y-axis. Class, where do you think we find the x and y-axis? Okay, the x-axis is at the bottom part of the graph. It represents the number of times water was used, and the y-axis represents the number of sips each time. And now, let us proceed in collecting and recording our data. So let's say the first time you reach for your water bottle, you were very thirsty, so you had 7 sips of water. Class, in which line of the graph do you think we put the dot to record the first sip of water? Anyone? Very good. So we put the dot here because you had 7 sips for the first time. Then for the second time and third time, you were less thirsty, so you had 3 sips each time. So in which line of the graph we will put the dots? So let us put the dot here and here. Okay? The fourth time, you only took 2 sips. So let's put the dot here. The fifth time, you got a little thirsty, so you took 5 sips, and we put the dot here. The sixth time around, you took 3 sips, and we put the dot here. And in the end, you were quite thirsty again, so you drank 8 sips of water, and lastly, we put the dot here. Okay, and this is now our collected data displayed in a discrete data line graph. So class, do you think are we done with this graph? This graph is done and complete since this is a discrete data line graph. We would not connect those dots because those dots represent 7 distinct actions. You were drinking only at those specified 7 times you recorded and not in between, meaning that you were not drinking continuously starting from the first time all the way through the 7th time. Always remember, discrete data can take a certain value and cannot be broken down into fractions and decimals. And now, let us proceed to our activity number 2, collecting and illustrating data to create a continuous data line graph. So based on your observation on the discrete data line graph, what do you think, or how do you visualize a continuous data line graph? Anyone? The class? Okay. So let us see what continuous data line graph is. What we're going to do is to collect data and we will measure the shadow of a flower between noon and evening. So again, let us have our table and let us have our table with the title at the center top of the graph. The growth of a flower shadow, and then the number of hours at our x-axis, and the length in centimeter at our y-axis. And now our graph is ready for our data. If the flower had no shadow at noon and you start to record the growth of the flower shadow after an hour and you got 3 centimeter shadow each hour until 6 p.m., what would be the graph look like? So where do we put our first dot if the shadow of a flower grows 3 centimeter for the first hour? Okay, let's put our first dot here because the shadow of a flower grows 3 centimeter for the first hour. Okay, for the second up to the last hour, it grows the same as 3 meters, 3 centimeters as the first hour. So we will put dots here, 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 and here. Since our measurements were taken on the hour, each hour the dots are placed above the numbers denoting the time. The shadow of the flower continuously grows throughout the entire time. It is during and between the time of the measurements. Since the growth is continuous, we represent the continuous growth by connecting the dots and forming a solid line. And this is now our continuous data line graph. And before we end, let me recap to you the difference between the discrete and continuous data. So the discrete data, it cannot be broken down into fractions or decimals. It can be easily visualized and demonstrated using simple statistical methods. Values can only take certain values and its graph contains of isolated points. For the continuous data, it is able to break down into fractions and decimals. It changes over time and can have different values at different time intervals. Its values can take any value, and its graph is unbroken. So for our visuals, please take a look at our continuous and discrete data graph. So our discrete data has isolated points, and our continuous data graph is unbroken and it has a connecting dots, line connecting dots. And that is all for today. Thank you and goodbye.